Hello students, let's take an example. In this example, train goes from station A to station B. Train starts from station A and it has to stop at station B. Separation between the stations is indicated 6 kilometers. And for the train, it is given that maximum magnitude of its acceleration is 1 meter per second square. That means the maximum acceleration is 1 meter per second square, and also maximum retardation on applying the brakes is also 1 meter per second square. The maximum allowed speed of the train is 60 meters per second. And we have to find the minimum time in which the train can complete this journey. Now, in this type of questions, there will be some parts of journeys, separate parts of the journey. For the first part, the train will be accelerating up to the speed of 60, up to its maximum speed. And then at that speed, it will move with a constant velocity. And finally, it has to retard so that it can stop at station B. You can pause the video and try it yourself. Alright, such questions can be solved most efficiently with the help of graph. We will draw the velocity time graph of the train, VT graph. See, initially the train will accelerate with its maximum acceleration so as to achieve this maximum speed in the minimum time. The graph will look like this. This is the maximum speed, 60 meters per second, and because the acceleration is 1, it will take 60 seconds to attain this maximum speed. You can apply the first equation of motion, v is equal to u plus at, to get this time here. Now, it cannot accelerate further, so it will move with this maximum speed, but then it has to retard because it has to stop at station B. So the stopping time we will try to minimize, because in order to minimize time, we would like the train to move at its maximum speed for the maximum possible time. So the time of retardation we will try to reduce, we will try to keep it minimum. And the time of retardation will be minimum if we choose maximum retardation. And the maximum retardation is also 1 meter per second square. So the slope of this line and the slope of this line, they will be same in magnitude. They will be same in magnitude. It will look like this. In fact, if the slopes are equal and height is also equal, so you can easily understand that this time of retardation also has to be 60 seconds. Because the magnitude of acceleration, magnitude of retardation are same, and the velocity range is same, 0 to 60. Here it is coming from 60 to 0. The time taken will be same. If you want, you can again use first equation of motion here to get this time. Now, what we need to find is this remaining time. How much is this remaining time? That is what we have to find. Let's see which information we haven't used till now. It is this: separation between the two stations is 6 kilometers. The distance traveled by the train, you can also say displacement of the train, because it's moving in just one straight line without turning. So displacement of the train is 6 kilometers. From this graph, how do we get displacement? Yes, you know velocity time graph. In a velocity time graph, area under the graph, this area tells you the displacement. Alright, so let's assume this unknown time to be some t2. let's assume this unknown time to be t2 and calculate this area in terms of t2. And we can put that equal to 6,000 meters. Alright. So first of all, this triangle, it has an area of half base into height. Base is your 60 seconds. Height is 60 meter per second. Alright. And by the way, this and this triangle, they are congruent. So we can simply multiply this by 2. So this is the total area of the two triangles plus the area of this rectangle in between is how much? It is 60 meter per second. That is the velocity times t2. So 60 meter per second into t2. This is the area of rectangle. This total area according to the question has to be equal to 6,000 meters. Alright. Now we can easily calculate the value of t2. 60 t2 is equal to 6,000 minus this will be 3,600. So t2 is 2,400 by 60 gives you 40 seconds. So with the help of this velocity time graph, such questions can be solved very efficiently in very less time, and also the time, the chances of error will be also very less if you use a very short efficient method. You can also do this by like solving part wise. You can use first equation of motion to get this time, and then you can use second equation of motion to get this displacement. Similarly, you have to do this for the third part, and then the total displacement you have to put equal to 6,000. Ultimately, you will get a similar equation to get the value of t2, but that method will be quite lengthy, more time consuming, and also chances of error will be large. So it's advantageous in such situations to draw VT graph. By the way, if we are asked that what will be the displacement time graph in such situations, so let me plot it here, displacement versus time graph. See, for the first 60 seconds, the train is accelerating starting with zero velocity. So the graph will have a parabola which is swinging upwards. Swinging upwards because it's a positive acceleration. So the slope of the graph has to be increasing. Remember, slope in ST graph represents the velocity. Increasing velocity means increasing slope. Initial slope is 0. So it starts from almost flat trajectory and it is swinging upwards. So this is till your first 60 seconds. Now for the next t2 equal to 40 seconds, the graph is going to be a straight line because velocity is constant. And what will be the slope of that straight line? Slope of the straight line will be this velocity. So, and this slope is actually the final slope of this graph here. So the same slope will continue for the next 40 seconds. Or in fact, I should write here 60 plus 40. So this becomes 100 seconds. And for the last 60 seconds of the journey, the graph is a retarding graph. Now the velocity is decreasing and final velocity becomes 0. So the final slope at the end of the journey should be 0. So the graph will look like this. This total duration will become 60 plus 40 plus another 60. So it is 160. So answer of this question is, you can see 60 here, this is 100, so this is 160 seconds. Alright, so the ST graph will look like this. If you want to write what is there, what are the displacement at these points, see displacement here will be area of this triangle. Area of this triangle you can see is half of 60 into 60. So it is how much? 1800. 1800 here. What was the area of this rectangle? Area of this rectangle is 40 into 60. So it is 2400. So 2400 plus 1800. So that becomes 4200 here. And this displacement is in, of course, meters. And at the end of the journey, of course, it has to be 6000 meter or 6 kilometers. So the displacement time graph, if you want to plot, it will look like this. Problem, of course, can be solved just by plotting the VT graph and doing the right calculation. Now this example is a very practical situation. Everyone encounters once or twice in your lifetime. See, this is a bus which is about to start, and this person here wants to catch the bus. He knows that the bus is about to start. So what he is doing, he is running at his maximum speed, which is 4 meters per second. He cannot accelerate further. He is going at a constant speed of 4 meters per second. But when his separation from bus is 6 meters, the bus starts with a constant acceleration of 1 meter per second square. Now the question is whether he will be able to catch the bus or not. If yes, when? If no, by what distance will he miss the bus? You can pause the video and try it. Okay. Now let's look at this problem. Now this is a situation in which two objects are moving. So in such a case, we must decide an origin. Our x equal to 0 point. So let's take the position of this man as our x equal to 0 point. That means the bus is initially at x equal to 6 meters. Now we will write down the coordinates, the x coordinates. It's a case of one-dimensional motion. So x coordinate of both man and bus as a function of time. See, man is running at a constant velocity of 4 meters per second. So the x coordinate of man, we can simply write it as 4t. What about the x coordinate of bus? See, for bus, because it is moving with some acceleration, we will use the equation s is equal to ut plus half at square. Now the value of u is 0 because question says it starts. So it starts to move. So u is 0. So first term is 0. Second term will be 1 into t square. Now what about this s? S represents the displacement. Displacement from the starting position of bus. Right? But the bus is already at 6 meters. So the displacement of bus we can write as x minus 6. See, s is the displacement. If I want to write the coordinates, I may have to replace this x by x minus x naught, where x naught is the coordinate of bus, is the position of bus at t equal to 0. Alright, because s is the displacement from this position. So the coordinate at that point we can get by adding a x naught to it. Right? So the x coordinate of bus will be given by 6 plus half t square. You can recheck this by putting t equal to 0. At t equal to 0, you are getting x equal to 6, which is the initial x coordinate of bus. Right? So this is the x coordinate of bus. This was x coordinate of man. Let me write this as xb. Okay. Now you will encounter many problems in which an object reaches the other object. Here, the man is reaching the bus. There may be a situation where a fielder reaches a ball, or two balls, they hit each other. So in such questions, the maths that we have to use is that their coordinates, they become same. If it is a one-dimensional coordinate, it is just x coordinate. If it is a, later on we will be doing two-dimensional or three-dimensional questions. In two-dimensional questions, we will equate both coordinates. In three-dimensional equation, we will equate all the three coordinates at that time, at the time of impact or at the time of one object catching the other. Alright, so what we have to do is, we will equate these two. If and when the person catches the bus, we are not sure yet, but if and when this happens, their coordinates will be equal. So let's put this 6 plus t square by 2 is equal to 4t. Now this can be written as t square minus 8t plus 12 equal to 0. This can be easily factorized. 6 into 2 is 12, so t square minus 2t minus 6t plus 12 equal to 0 gives me t minus 2 times t minus 6 equal to 0. So we are getting two roots for t as t equal to 2 and 6 seconds. So we are getting valid solutions, but there are two solutions, 2 seconds and 6 seconds. So which one should we which one should be our right answer? See, maths is only a tool for us. Maths works in its own way. In physics, we have to take decisions in such situations. Put yourself in place of this person and think. You are desperate to catch the bus. What will you do? You will do it in the first opportunity that you get. So the answer should be t equal to 2 seconds. The person will catch the bus at 2 seconds. What is the significance of the other solution? That we will see by plotting the graph. We will plot the displacement time graph or the position time graph of both man and the bus, and we will see the significance of second solution. The xt graph of the man for t, very simple, will look like this. Okay. At t equal to 0 it is 0, and at t equal to 1 it becomes 4, at t equal to 2 it becomes 8, like that. Now the x coordinate of bus, at t equal to 0 x coordinate of bus is 6. So the graph will start from here. At t equal to 0 the bus is already here, and then half t square, positive acceleration. So it will be a parabola swinging upwards. The slope should be increasing. So the graph will be like this. Now we know that at t equal to 2 seconds he catches the bus. So this will be the common point, and then another common point we will get somewhere here. This is the other solution at 6 seconds. But will this actually happen? Will the bus keep going like this, and the man going will the man keep on going like this? In a practical situation, no. Man is desperate to catch the bus, so he will climb the bus here itself, and then his graph will merge with the graph of bus. We should make this a dotted line, isn't it? So you have to think practically in such situations. I am now making one change in the previous question. This distance I have made 16 in place of 6. Question is same, whether the person will be able to catch the bus or not. If yes, when? If no, what is the minimum separation between man and bus? That means by what distance he misses the bus. Alright, let's try this. So the solution will change accordingly. The 6 here, I will replace it by 16. The x coordinate of man is same, 40. X coordinate of bus becomes 16 plus half t square. And again, if and when man catches the bus, we should have their coordinates equal. Alright, let's try to solve this quadratic. It will become t square minus 8t and plus 32 equal to 0. So the roots can be written as, or before the roots, let's try to find the discriminant. So the discriminant of this equation is b square minus 4ac. b square means 8 minus 8 squared minus 4 times a is 1, c is 32. So you can see that this is negative. So if discriminant of a quadratic is negative, its roots are imaginary. What does imaginary root imply here? It implies that he can only imagine to catch the bus. If the roots were real, like in the previous case, he could really catch the bus. If the roots are imaginary, he can only imagine to catch the bus. How will the graph look like? The graph of graph of the man is same. At t equal to 1, it is 4 meters. This is x, this is t here. At 2, it is 8, like this. But the graph of bus, it will start from 16. The bus is already 16 meters ahead. So it will start from 16 and it will go something like this. The two graphs are not intersecting. That is what we are getting. There are no real solutions of this equation. Discriminant is negative. Graphically, what it means is that the two graphs, they don't have a common point. So it shows that the person will not be able to catch the bus. Now, the second part, by what distance he misses the bus, or what is the minimum separation between man and the bus. So one way of doing it is to minimize the separation. What is the separation? Separation we can get by subtracting the two x coordinates. X coordinate of bus minus the x coordinate of man. Let's call this separation function delta x. So delta x we can write as 16 minus 16 plus half t square, which is xb, minus xm, which is 4t, and we will minimize this. So derivative of delta x by dt gives us 16 is a constant, t square by 2, it will be simply t minus 4. If we put it equal to 0, so the separation will be minimum at t equal to 4 seconds. We can find the minimum value of delta x just by putting 4 in this expression. So delta x minimum will be 16 plus t square by 2. 4 squared by 2 is 8 minus 40. 40 is 16. So the minimum separation is 8 meters. So this was using maxima and minima. The another way of finding minimum separation is the analytical way. Look at it this way. At the initial moment, the bus had velocity 0. Man was running towards the bus at 4 meters per second. The speed of bus keeps on increasing at the rate of 1 meter per second. Whereas the person is moving at a constant velocity. Now, as long as the velocity of person is greater than the velocity of bus, the separation between them will keep on decreasing. But when the velocity of bus becomes greater than the velocity of person, separation between them will again start increasing. So what is the moment when the separation is minimum? Right, it is when the velocity of bus becomes equal to the velocity of man. At that instant, the separation is minimum. Alright, because after that, the velocity of bus becomes greater and the separation starts increasing. So it is minimum at that moment. Now, velocity of the person is of course constant 4 meters per second. When will the velocity of bus become 4 meters per second? Initially it is at rest and it is having a constant acceleration of 1. So you can say velocity of bus u plus 80, 0 plus 4t and 0 plus 1 into t, 1 is the acceleration, and put this equal to 4, you get t equal to 4. The same result which we got using maxima and minima. Here we were differentiating the separation of bus and man. Okay, and here we have got this by equating the velocities. So at 4, the velocity, the separation is minimum, and you can calculate the separation here. Graphically, what happens is that the separation is minimum at the moment when the slope of the graph, that means if I draw a tangent on this graph, the point at which this tangent becomes parallel to the graph of man. See, this was the graph for man, this is for bus. The moment where the slope is parallel to this graph, at this moment the separation is minimum. This is delta x minimum if you want to see it in the graph. Now here is the third part to this problem. This time we have to find the minimum initial separation of the man from bus so that he can just catch the bus. We have seen that he can catch the bus if the separation is 6. We also know that he cannot catch the bus if the separation is 16. So there must be a value of initial separation between 6 and 16 so that he is just able to catch the bus. So we have to find that maximum possible initial separation so that he can just catch the bus. So what do? We have written the x coordinate of man as before as 4t, and for the bus we can say it will be x minus L equal to 0 plus half into 1 t square. S we have written as x minus L. L is the initial x coordinate of the bus. Initial velocity of course is 0. Acceleration is a. So x coordinate of the bus we can write as L plus half t square. Now if he catches the bus, we equate the two coordinates. So L plus t square by 2 equal to 4t, and we get t square minus 8t plus 2L equal to 0. Now, we know that he will be able to catch the bus if the solutions of this equation are real. And condition for real solutions of a quadratic equation is that discriminant should be greater than or equal to 0. So, what is the discriminant? Discriminant b square minus 4ac. B square is your minus 8 squared. B square minus 4ac. So, minus 4 times a is 1, c is 2, 2l. So, we want this to be greater than or equal to 0. This discriminant to be greater than or equal to 0. So, this gives us L equal to 64 divided by 4 into 2, 8, which is 8 meters. So, this is indeed a value as expected between 6 and 16. 8 meters. If 8 meters is the separation, he will just be able to catch the bus. What will be the graph like in this case? Graph will be like this, that the graph will be just touching this bus graph at one point. At one point, the graph of bus is just touching the graph of man. This is the straight line graph is for man, the curved graph is for bus. X versus t, the bus started from L equal to 8 in this case. So this is a critical case where he will get just one opportunity to get into the bus. Hello students, today's class we will be starting with a small demonstration. हाँ, अपने फिंगर्स को ऐसे खोल के रखो. मैं स्केल को छोड़ूंगा, तुम्हें इसको पकड़ना है, ठीक है? Okay, let's see what he has done. He has caught the scale at around 20 centimeter mark. So, what does this tell us about his reaction time? See, the scale was in a state of free fall. So, it has travelled a distance half gt square. Initial velocity of the scale, as you could see, was 0. So, this half gt square is equal to 0.2 meters. So, we can calculate the reaction time T as 0.2 multiplied by 2 upon value of G is, we are taken 10. So, this square root of this. Alright, so this becomes approximately 0.2 seconds. So, this is the estimated value of a person's reaction time. Now, what is the role of reaction time while we drive some vehicle? Suppose you are driving a vehicle on a road, suddenly you see some danger in front of you and then you apply the brakes. So, what is the reaction time? Reaction time is the time's gap between when you see the need to take an action and actually that action is taken. The gap between these two instances, we can say, is the reaction time. In this experiment, the person had to catch the scale, but he could do it only after it had fallen a certain distance. Because our body, it takes some time to respond. Alright. So similarly, while driving, when we see some danger in front of us, Only after that we apply the brake, and then the vehicle also, it takes some time to stop. It can't stop suddenly because because the retardation of the vehicle after the brakes have been applied will after all be finite. Here is an example based on reaction time. This vehicle is going at a speed of 72 kilometers per hour. Suddenly, a wild animal jumps in front of the vehicle at a distance of 45 meters from in front of the vehicle. The maximum retardation that we can have on applying the brakes is 5 meter per second square, and reaction time of the person is 0.2 seconds. Question is, will there be an accident? Pause it, pause the video and try it. Alright. See, for the first 0.2 seconds, that is during the reaction time, the vehicle will be moving with this constant speed. So of course, you can convert this to meter per second. This will be 20 meter per second. So for the first 0.2 seconds or during the reaction time, the vehicle is moving at its original speed of 20 meter per second. Then the brakes are applied. See, what is the meaning of reaction time? The person saw a need to apply the brakes, but then the body took some time in reacting, which is 0.2 seconds. So the brakes are actually applied at this moment. After this, the vehicle will have a retardation of 5 meter per second square. So there are two parts of the journey. In the first part, the vehicle is moving with constant velocity and then it is retarding. The problem can be solved very efficiently if you draw velocity time graph. VT graph will have two parts. First part will be flat. During the reaction time, the vehicle is moving at a constant speed, which is your 20 meter per second, and then after 0.2 seconds, when the brakes are actually applied, it has a retardation and it comes to a halt somewhere here. Now, how much time will the vehicle take in coming to a complete stop? We can easily calculate. The speed will drop by 5 meter per second every second. So from 20, it will take 4 seconds. So this time duration here is 4 seconds. So the total time here will be 4.2. Of course, you can get this time by using your first equation of motion also. You can put v equal to 0 and u is the initial velocity 20 plus acceleration minus 5 times the required time t, this one, or t2 you can call it. So t2 you will easily get as 4 seconds, or you could have done it directly. So this is our VT graph. Now the total displacement of the vehicle before it stops, we can get it by this area under VT graph. So how much is the total displacement of vehicle? It is area of rectangle plus the area of triangle. So area of rectangle is 20 into 0.2 plus area of triangle is half, base is 4, height is 20. So you can see this is 40 plus 4, 44 meters, and the given original separation was 45.0. So the animal is just saved, and also the vehicle and the person in it, but that was very close. So that is why they say that driving at high speeds can be dangerous. Alright, and particularly during the night time when you can only see up to a certain distance. So it's better to go slow and be safe during a drive.